The first circle in this row has radius 1. Each other circle has a radius that's 4/5 of the radius of the circle to its left. If we assume these go on forever, we get a picture that looks like this. The first 3 circles have their radii labeled. I want to write a series whose sum represents the total area of all these circles. So we're supposed to use summation notation, but I always like to start by just writing it out. So the area of this first circle is pi times 1 squared, or just pi. And then the area of this second circle is pi times 4/5 squared, or 16/25 pi. And then the second circle, its area is going to be pi times, the radius is 4/5 times 4/5, so that's 16/25 squared, which is 16/25 squared. Can't quite do that in my head. So I've got 16 squared and 25 squared, 256 over 625 pi. And then my next one, its radius is 4/5 times 4/5 times 4/5, which is 4/5 cubed, 64 over 125. So this is pi times 64 over 125 squared. Which is 0.262144 pi. Okay, so my sum, when I add up all these areas together, I have pi plus 16/25 pi plus 256 over 625 pi plus whatever that is, 0.262144 pi plus dot dot dot. All right, so this thing, it turns out, is geometric. To get from each term to the next, you multiply by 16 over 25. Right, 16 times 16 is 256, 25 times 25 is 625, and then we should double check that times 16 over 25 gives me this decimal. So 256 over 625 times 16 over 25 is that decimal. So yeah, we got it. So this thing is geometric. That's going to help me come up with the final sum, but first thing I want to do is write this in summation notation. So every term has a pi times it, and this is going to be the sum of my first term, let's see, 16 over 25. This is all 16 over 25 to a power, and I want my first term to be a 1, so I should start at n equals 0, go to infinity. But so this term is this pi term is to the 0. This is 16 over 25 to the first. 16 over 25 squared is 256 over 625, so this is to the nth power, right? Or you could start at n equals 1 and raise 16 over 25 to the n minus 1. Either of those is fine. So the total area of the circles is finite because this is a geometric series whose multiplier is less than 1. My R value is 16/25, which is less than 1, so I know I have convergence. And what I converge to is A over 1 minus R. My first term is pi, and my multiplier is 16 over 25. So this is pi times 25 minus 16 is 9 over 25, 25 pi over 9.